Welcome. In this video, you will learn how to determine if a function is even, odd, or neither. Let's start off with the definition. So a function is even if this holds. This means if you plug in a negative x, you will, after some simplification, be able to get back the original function. So the negative goes away. A function is odd if this holds. This means that if you plug in a negative x, after some simplification, you're going to get back the original function, but with a negative. So the negative comes on the outside. So that's a great way to remember. What happens to the negative? The negative goes away, and the negative comes on the outside depending on which function you have. So now let's do a few examples. Determine if the following function is even, odd, or neither. So we need to start off always by plugging in a negative x and keeping track of the negative. So you need to be very careful. I recommend to put parentheses everywhere that you see an x and replace it with negative x. So we're going to replace x with negative x here. And then we have 3 over 4. So all we did was plug in the negative x. Now we're going to try to simplify and keep track of the negative. So in the first parentheses, because we are raising this to an even power, the negative is going to go away. So you're left with 3x to the 8. Then we have a minus. Now in the next term, we're raising this to an even power, so the negative is also going to go away here. So then we have x to the 4. Now at the end, we just have 3 over 4. Look at this. This is the original function. So what this means is that this is just f of x. So the negative went away and you got back the original function. So you can conclude that this is an even function. Let's do another example. Same question, but now we have a different function. We're always going to start off the same way. Plug in the negative x. Let's do it. So I have 8 parentheses negative x to the 7 plus 3 parentheses negative x to the 3. Let's simplify. So we have an 8 and we are raising negative x to the 7 because that is an odd power. The negative is going to come on the outside. So then we have negative 8x to the 7. Okay, let's keep going. So we have plus 3. And now we're raising this piece to an odd power, so the negative is going to come on the outside. So instead of plus 3, we're going to have minus 3x to the 3. Take a look at this. This is not the original function. This means that this is not an even function. Okay, if it's not even, maybe it's odd. How do I know? Try to factor out a negative from the entire thing, and let's see what we get. So we're going to factor out a negative. So let's think this through. We had 2 terms to begin, so I should expect there to be 2 terms in the parentheses whenever we factor out a number. We're factoring out a negative, so the only thing that's going to change is just the signs. So I'm going to be left with 8x to the 7 plus 3x to the 3. That's a quick little trick. Every time you factor out a negative, it's just going to switch the signs. But you should always check your work. Go ahead and distribute the negative and make sure that you get back the previous step. And we do. So we did it correctly. Now, let's analyze what we have in the parentheses. In the parentheses is the original function. So what we have here is negative times f of x. That means that you have an odd function. The negative, so when you plug in a negative x, what happens? The negative comes on the outside. All right, let's do another example. Same question, different function, and we're always going to start off the same way by plugging in a negative x. So let's plug in this negative x and keep track of that negative. Okay, now that I have plugged in the negative x, let's try to simplify. So within the first piece here, I have an even power. Because I have an even power, the negative is going to go away. Then I have a negative and a 7, and I analyze what I'm racing this to. I'm racing this to an odd power, so the negative is going to come on the outside, and it's going to make the negative 7 a positive because two negatives become a positive, and I'm left with this. This is not the original function because of this negative. It almost is. Look at this. This is positive, positive, but then we have here negative, and this is positive. So they're not the same. So you always check first to see if you have an even function, and we don't. The second thing that you're always going to do next is determine if you have an odd function by factoring out a negative. Now remember, when we factor out a negative, all that we end up in the parentheses is just the original, but with the opposite sign. This is what we get. Now let's analyze what we have in the parentheses. Is this the original equation? And the answer is no, it is not the original one. So it's not even and it's not odd. The conclusion is that this is neither. So let's summarize what we did. Plug in a negative x. We first determine if it's even, and if it's not, then we determine if it's odd, and if it's not, then the answer is neither. Let's do another example. All right, so now let's plug in a negative x. And at the top, I'm going to get negative x to the 3 minus negative x over parentheses negative x squared plus 1. And let's simplify. So in the top left, I have an odd power, so the negative comes on the outside. In the second term, I have two negatives, which make it into a positive. In the bottom, I have an even power, so the negative just goes away. Is this the original one? Well, the answer is no, it is not. So it's not even. Now I'm going to try to factor out a negative from the entire thing. Now, where am I going to factor out the negative? From the top or the bottom? Well, take a look at the original one. This is almost this. The bottom is exactly the same. So I'm going to factor out the negative from the top. Let's factor out the negative from the top to get x to the 3 minus x. And in the bottom, I'm left with the same thing. Take a look at this. This piece here is exactly that function. Therefore, what we have here is negative times f of x. This means that our function is odd. Let's do one more challenging problem. Number 5. Start off the same way. Plug in the negative x, and at the top, we're going to get negative x to the 9 minus negative x to the 5 plus negative x all over negative x plus negative x to the 3. All right, well, let's simplify each term and see if the negative goes away or if it comes on the outside. So at the top, first term on the top left, right there, I have an odd power, so the negative comes on the outside. Next term, power of 5, that is odd, so the negative comes out, and it combines with the negative that was already there to get a positive. So I have positive x to the 5. At the last term, I just have a negative x. Moving on to the bottom, focusing on this, not much to do, just remove the parentheses. Going on to the last term, because it is a power and the power is odd, the negative comes out. Okay, let's analyze this. Is this the original 1? It doesn't look like it. However, let's analyze this a little bit carefully this time before we conclude that it's not an even function. What's the difference? Well, this is positive, this is negative. And look at this. They alternate signs. They alternate signs. Alternate sign. And even in the bottom, they alternate signs. So let's do this. Let's factor out a negative from the top and from the bottom. And then let's see what we have. So in the top, if we factor out a negative, I'm going to get x to the 9 minus x to the 5 plus x. And in the bottom, I'm going to have x plus x to the 3. And on the left here, notice I have two negatives, so they're going to cancel out to get a positive. So what am I left with? I'm left with x to the 9 minus x to the 5 plus x all over x plus x to the 3, which is the original function, f of x. Therefore, this is even. So what we can learn from this one is sometimes you can manipulate it a little bit more to get back the original function.